Hello everyone. Today I'm going to report our recent study that named Material Transfer Planning for Huge Warship, Modeling, Simulation, and Evaluation. This work is attributed to the 713 Research Institute of CSSC, Zhengzhou, and School of Computer and Artificial Intelligence, Zhengzhou University. In this study, we focus on the transfer of huge warship materials. The warship materials are a collection of consumables on a carrier, such as aircraft tires, aviation missiles, ammunition, and compressed oxygen. As vital military supplies, they need to be transferred fleetly when needed. Inefficient material transfer or risky material support operations can prolong the support cycle of carrier-borne aircraft, affect the sortie rate of aircraft, and harm the combat capability of warships. However, as shown in the cross-section of an aircraft carrier, warship materials are stored on the lower deck, while their destination is mostly the flight deck. Therefore, how to plan the best transfer route of materials becomes a problem worth studying. A task that requires the transfer of specific materials from the lower deck to their destination is called a material transfer support operation, and our goal is to optimize the completion time for all support operations. The warship material transfer support process involves several transfer operations, each of which aims to safely transport the corresponding warship materials to the designated location. This slide shows a typical transfer process of support operations. Upon receiving the transfer operation from the command center, the material transfer support system will take out the required materials from the storage cabin. The materials are transported from the lower deck to the transfer room through vehicles and elevators. After that, the materials are assembled, inspected, and adjusted. The inspected materials can be transferred to the upper deck in two different ways. One is direct transport to the flight deck by elevator and transfer to the target position on demand. One is transport to hangar deck by elevator first, then arrive at the flight deck by dedicated aircraft elevator and finally transfer to the material catch area or target position. To formulate the problem, we first analyze the transfer process and find that the choice of different machines determines material's final transfer route. Such a problem has the characteristics of stage, sequence, and continuity. Thus, the problem of warship material transfer support can be considered as a kind of flexible flowchart scheduling problem that machines are irrelevant and parallel. Next, a warship material transfer support WMTS model is proposed to formulate the problem. In this model, there are some materials in various types that need to be transferred in a scheduling period, and these materials will reach their destination through many stages. Materials go through this stage in the same order, but the equipment chosen in each stage can be different. Moreover, there are some assumptions to clarify the model. With these assumptions, the warship material transfer support problem is transformed into a special flexible flowchart scheduling problem, and the transfer process is shown in the figure. Based on the analysis of the problem, we built a mathematical model to minimize the maximum transfer time as given below. It consists of an objective function and a number of constraints. These constraints are designed based on real problems. Based on WMTS model, a great genetic algorithm is proposed to solve it. In summary, the GGA has 6 features worth mentioning. First, we divide the problem into 2 subproblems and code them with chromosomes respectively, which are called machine select and operation sequence. Genes of these 2 coding paths are represented by integers. Second, we use heuristic rules to generate an initial population based on an optimal retention strategy, which can preferentially select equipment with a shorter operating time and ensure load balance among equipment. Third, the fitness function is designed considering the objective function. Fourth, we use a ruled strategy to select individuals in the population. Fifth, we use 2 different methods called position-based crossover and linear order crossover to select the best individuals in failure generation. Finally, the sort of variable neighborhood search is adopted to make up for the deficiency of genetic algorithm in local searchability. To evaluate the proposed algorithm, we conducted 2 experiments. In numerical experiment, GGA is run on benchmark computation examples, and its results are compared with other algorithms like CGA, IGA-VNS, and IACO. The results are shown in the table. From the results, it can be noticed that the classical genetic algorithm only finds the optimal solution in 3 computation examples, while GGA finds the optimal solution in all computation examples, which has excellent performance and is comparable with other excellent algorithms. In another simulation experiment, we designed a transfer support problem with 5 stages and 6 material types. As shown in the table, GGA also performs best in minimum duration, average duration, and mean relative deviation. A reasonable explanation is that GGA uses a dual-layer code designed for material transfer support operations and introduces various operators, which optimizes its performance. This optimization method makes the algorithm avoid unreasonable solutions, improve its search efficiency and population evaluation rate, and ultimately improve the convergence speed and solution quality of the algorithm. In this paper, we first analyzed the Warship material transfer support process and proposed the WMTS model based on flexible flowchart scheduling problem. Then, a greedy genetic algorithm is used to solve the optimization scheduling problem of material transfer support operations. Moreover, we carried out simulation experiments on the material transfer support operation scenario, and the results show that the proposed model and algorithm can solve the problem effectively. Thank you for listening. If you are interested in our work, the following email address can help you to contact us.